Device isolation techniques. The most transistors that comprise an integrated circuit must be electrically isolated from each other during fabrication. Isolation is required to prevent unwanted unwanted conduction paths between the devices, to avoid creation of inversion layers outside the channel regions of transistors, and to reduce leakage current. To achieve a significant level of electrical isolation between neighboring transistors on a chip surface, the devices are typically created in the dedicated regions called active areas, where each active area is surrounded by a relatively thick oxide barrier called the field oxide. One possible technique to create isolated active areas on silicon surface is first to grow a thick field oxide over the entire surface of the chip, then often to selectively etch the oxide in certain regions to define the active areas. This fabrication technique called etched field oxide isolation is already illustrated in Figure B and Figure C. Here, the field oxide is selectively etched away to expose the silicon surface on which the most transistors will be created. Although the technique is relatively straightforward, it also has some drawbacks. The most significant disadvantages is that the thickness of the field oxide leads to rather large oxide steps at the boundary. Thickness of the field oxide leads to rather large oxide steps at the boundaries between active areas. And isolation field regions. When polysilicon and metal layers are deposited over such boundaries in subsequent process steps, the sheer height difference at the boundary can cause cracking of deposited layers, leading to chip failure. To prevent this, most manufacturers prefer isolation techniques that partially recess the field oxide into the silicon surface, resulting in a more planar surface topology. Thank you.